So as we kind of investigate, our goal today is this. We want to be able to graph y is equal to sine of x. And in order to graph y is equal to sine of x, and what we do is we plug in an angle in for x, and specifically a radian measurement. We plug that in for x in order to get um, the output. Okay, so this means that we need to look at the unit circle, at the angle measures, and the terminal points to see what the results are. So a little bit of a review about the unit circle, which you should know all about because you were supposed to test today, but you're not. You're testing tomorrow because of our little delayed start. And we're going to just map out the terminal points here. Make sure you remember them all. What is that terminal point right there? 1, 0. Very good. What is this terminal point? 0, 1. How about this one? Negative 1, 0. And this one? 0, negative 1. Excellent. Now, understand the radian measurements that go along with them. This is a radian measure of 0 radians. This is a measure of how many radians right here. Pi over 2. This is a measure of pi radians. This is a measure of 3 pi over 2 radians. And if you go all the way around, we have 2 pi radians. Everybody agreed? Okay. I'm going to add a few more to our unit circle. For example, this coordinate right here would make a 30, 60, 90 right triangle. And we've understood that that coordinate is the root of 3 over 2, 1/2. Agreed? And if we write the root of 3 over 2 as a decimal, it's 0.86. And 1/2 as a decimal is 0.5. Does anybody remember what the terminal point is for your 45, 45, 90? Root of 2 over 2. And if you write that as a decimal, it's 0.7071. We'll just write 0.71, 0.71. And then if we go 60, 30, 90, anybody know what that coordinate would be as a decimal? Yep, we got 1/2 and the root of 3 over 2. So 0.5 and then 0.86. There we have it. All good? Tell me what happens to the y values as I start at 0 and I go to pi over 2. What happens to the y values? They get bigger, right? What happens to x values? They decrease, right? How about over here? Here I'm going to have, another coordinate. It's going to be negative 0.5 and positive 0.86. So our terminal point is negative 1/2 and root of 3 over 2. This one will be negative root of 2 over 2, positive root of 2 over 2, or negative 0.71, positive 0.71. And this one right here, anybody want to guess? Negative 0.86, positive 0.5. So what happens to the x values as you get over into this quadrant? They become negative, right? And they become even more negative, right? They go from 0 over to negative 1, right? Whereas the y values, what happens to the y values in this quadrant? Yeah, they get smaller. They start at 1 and then they go down to 0. So when we graph y is equal to the sine of x, y is equal to the sine of x, is sine the x value or the y value? It's the y value. So it's going to have behavior like the y values. It's going to start at 0 and it's going to get bigger. Then it's going to get smaller. Then it's going to become negative, and then it's going to get less negative and come closer to 0, right? That's what sine's going to do. And so if you think about the graph, if the graph is positive, it sits above the x-axis. So we'll be above or below in this quadrant. Above, above, below, below. And in fact, once you go around the circle, won't it then just repeat itself after that? It will just repeat itself over and over and over again. And so, as I make this graph, the first thing that I'm going to choose to do, a lot of ways to represent this, but I'm going to choose to write this graph. The x values, I'm going to go out to 2 pi. Because once you go all the way around, it's just going to start to cycle again and do the same thing, isn't it? And I'm going to take that 2 pi, I'm going to divide it into 4 parts because it has 4 quadrants. And then as we look at that unit circle, what's the biggest value that y can ever be? 1. What's the lowest value that sine can ever be? -1. So it's going to go all the way up to 1. It's going to go all the way down to -1. So we're going to plug in an angle value for x, and then the output will be, for a sine, will be the y value. So what is the sine of 0 radians? 0. What is the sine of pi over 2 radians? 1. You're looking for the y value. What's the sine? Whoop, I'm sorry. Sorry about that. And I really don't like my graph. I'm going to change it right now to just make it a little bit more dimensional. Make +1 and -1 here. There we go. So we said at pi over 2, the sine value is equal to 1. You're correct. How about the sine of pi? The sine of pi is 0. Again, you're looking for the y value of the terminal point. What's the sine of 3 pi over 2? -1. And what's the sine of 2 pi? 0. Now, if you look at the values in between, you can understand a little bit more what's happening as well. Let's look at the y value here at pi over 4. This is pi over 4. You get 0.7. So at pi over 4, about halfway in between, I'm going to be up at 0.7. Now, if I go between pi over 4 and pi over 2, it looks like the y value is 0.86. So if I go between those, I have a value that's even higher, 0.86. But if I go at a value that's between pi over 4 and 0, say pi over 6, then the value is 0.5. So if I go between there, I get like 0.5. And see how I put all those dots there? So you can see it's going to go up, and then it's going to come down. So this is the shape that you get. We end there, and we'll pick up right after lunch. Here we are. What shape does the sine function make? A wave, and waves are very applicable. For example, as I speak to you, my voice travels as a sound travels as a wave. What else travels as a wave? Light. Very cool. So here's what we've learned. If you are considering how to graph this function, we know that the amplitude is the distance from the center of the graph to the top, or the center of the graph to the bottom. And the amplitude of the sine function in this case is just 1. If you put a coefficient in front, then the amplitude ends up being the absolute value of A. We always say that the amplitude is positive. Now, here's another thing that's interesting. The sine function, after it gets to 2 pi, what's it going to then do after that? It will repeat itself, right? And so therefore it has what we call a period, where then it goes through the exact same course that it once encountered. Yeah, makes sense, doesn't it? Yeah. So therefore the period would normally be 2 pi. But if we have a value of b in front, the period ends up being 2 pi over b. 2 pi over b. That is the basis for graphing sine and as well as cosine. Please flip to the very front. We can do a couple problems on your worksheet for you. The graph of y equals 2 sine of x. We have the amplitude. Anybody want to identify the amplitude? It is 2. The period is 2 pi divided by the b value. What is the b value? What's the value sitting in front of x? 1. So the period is 2 pi. So I'm going to mark out 2 pi and divide it into 4 parts to represent the 4 quadrants. I'm going to mark 2 for the maximum spot and then -2 for the minimum spot. That's the structure of my graph. I can now place the graph of 2 sine of x onto that. So we have 2 sine of x. Remember, the sine of 0 is 0. And if you multiply by 2, you would still get 0. Do you remember what the sine of pi over 2 was? It was 1. And if you multiply by 2, you get 2. So you can see it starts in the middle, and then it will head to the maximum. Where do you think it goes after that? Back down to 0. Where do you think it goes after that? Down, and then back up. And so those are the important points to identify where it crosses the x-axis and also the maximums and minimums. Now, if you back up at negative pi over 2 here, do you think it'll be up, middle, or down? Which one do you think it'll be? Down, yeah, it follows that same pattern. So just think of the pattern of the wave, and it follows suit with that. There you have it. Now, I'm going to come around and glance at your wave. Let us try a different one. We have 4 cosine of x over 2. 4 cosine of x over 2. What's different about this one? Cosine graph. We'll consider that in a second. The amplitude, kind of the formula stays the same. It's the absolute value of a, so the amplitude will be 4. And then the period is going to be 2 pi divided by, what number is in front of x? What are you multiplying x by? 1/2. So 2 pi divided by 1/2. Anybody? 4 pi. Excellent job. That's a great story. Second place is the first loser. That's another way to think of it, I guess. Okay, now let's think about the cosine graph. Cosine is different. You don't have to flip back, but look at my unit circle. Again, the circle of life, this produces all of the things that we want to think about for trigonometry. It's really, really quite incredible. Cosine and sine are different how when you think about the unit circle? Sine is the, and cosine is the x. So cosine is the x value now. So now we're looking at the x value. So the cosine of 0 is 1. So instead of starting at 0, it starts up at, and then what happens after that? It goes down to, and then after that, it becomes negative to -1, right? And then it comes back up to 0, and then back up to +1. So it's everybody see how it starts up at the maximum? The largest that cosine can be is 1. It starts there right away. So excellent job recognizing that. Again, I just want you to see that unit circle rotation. It's exactly what we're looking at with the sine graph and the cosine graph. So the cosine function, the cosine of 0 is 1, and then you multiply by 4, you get 4. So it starts up there. Where do you think it heads from there? Yep, crosses over 0, then all the way to the bottom at -4, back up, and to the top. A couple really important things for you to identify here. I'm going to give you an opportunity to really take something and get a little bit smarter. Okay? Are you ready? Right here, remember 0 to 4 pi, I broke that up into 4 parts to represent the 4 quadrants, right? Where is cosine positive? Which quadrants? 1 and 4, right? Look, the curve is above the x-axis there and there. First quadrant, fourth quadrant. Where's cosine negative? 2 and 3. It's negative second and third quadrants. You see that? So again, the sine and cosine graphs are simply the unit circle just unraveled onto an x and y axis. It's the same thing. We're just putting it all on a graph, which is really quite beautiful. I mean, it's really neat how it takes shape and form. Now, as you look at your graphs, your waves, I want you to know that all the waves I see right now are acceptable, but this is where I draw the line. I'm a pretty forgiving teacher. I tend to give a decent amount of, kind of partial credit, and that may just be my opinion. You may have a different opinion, but by and large, if you surveyed people, they'd say I'm pretty forgiving in my kind of partial credit. Here's where it's tough for me, folks. Okay, so somebody draws a graph like that, and then another person they draw that. That's what their graph looks like. Now, I would be lying if I said I've never had a graph like that looks like that on a test. I have definitely had a handful of graphs where people put that on a test, and then they wonder why I take a point off, and I say, well, because that's a really, really bad graph. Well, you knew what I meant. Well, no, actually, I don't. I don't know what you mean. I really don't. So to me, that's not a representation. It's not accurate at all. I can't, in good conscience, give that the credit that you would like. You guys all understand kind of my boundary for what I'm accepting and what I'm not? Okay. Oh, that's beautiful. That would be an A plus exceptional graph. Some people tend to draw kind of these like, pointy shapes. It is. I encourage you to draw a little bit of a curve with it. Again, I'm not here. I don't see anything that's unacceptable from you guys. But I want to tell you, just don't push me too far. You give me something like that, and I'm going to get a little bit upset about the situation. Okay, flip it over. No, doesn't deserve a call home. Just deserves you need to grow up. Have better handwriting. Okay, number 11. Amplitude. Positive 2/5. Amplitude is always positive. It's the absolute value of the number in front. Never write that the amplitude is negative. It is always positive. In order to find the period, I take 2 pi and divide it by what? How do I divide something by 3/5? I multiply by 5/3. What is 2 pi times 5/3? 10 pi over 3. So I get 10 pi over 3. Excellent. So I'm going to mark out 10 pi over 3 and negative 10 pi over 3. Now we'll see how good you are with fractions. This has nothing to do with trigonometry. It has everything to do with fractions. I'm going to take 10 pi over 3 and divide it into how many parts? Why 4? To represent the 4 quadrants. So 10 pi over 3, I divide it in half. 10 pi over 3 divided by 2. 5 pi over 3. Very good. I'm going to take 5 pi over 3 and divide that by 2. Or, how'd you get that? Yeah, so 5 pi over 3 divided by 2 would be like 5 pi over 3 times a half, right? So dividing by 2, you can multiply by half. 5 pi over 3 times a half would be 5 pi over 6. Now, in order to get the third tick mark, you just take the first tick mark and multiply by 3. What is 5 pi over 6 times 3? 15 pi over 6. Let's reduce that. You get 5 pi over 2. So 5 pi over 6, 5 pi over 3, 5 pi over 2, 10 pi over 3. Not as intuitive to think through, is it? Got negative 5 pi over 3, negative 5 pi over 6, negative 5 pi over 2. Good times. I'm going to mark the top as 2/5 and the bottom as 2/5, but it's negative. Give you a chance to get caught up here. Okay, so what's different about this sine graph It is negative. This one just 30 seconds. Trust me, you'll be fine. Does sine start at the maximum or in the middle? Do you remember? It starts in the middle. If it's negative, instead of heading up, it's going to head down. And so if it heads down, you're going to get then that kind of a shape. We're going to pick up with you can definitely do some of the problems on your worksheet, and we'll give you a little bit of time to practice more of these tomorrow, but we'll also be jumping into something else. Oh, I'm sorry, no, we're testing tomorrow, right? So Friday we'll pick up with this a little bit.